Now see the redistribution of charge. Redistribution of charge due to presence of other conducting body. So let two spherical conductors kept concentrically having radius r and 2r and the charge q and minus 2q given on its surface. So find the charge distribution on each surface. So now the question is that two concentric spherical conductor of radius r and 2r having charge q and minus 2q respectively, two concentric spherical conductor of radius r and 2r having charge q and minus 2q respectively, find the charge distribution on each surface of each conductor. Now this is the situation. How to solve this one? So this we can say, let example number 1. See, first of all, the concepts involved here, 2-3 concepts we can follow here. Concepts involved. See, first one we can write conservation of charge. Conservation of charge. Second concept we can use Gauss law. And third we can say, if any conductor earth is earth, then its potential will be zero. And fourth we can say, if two conductors are connected together, so their potential will be same. And fifth point we can say, inside a conductor electric field is always 0. Inside a conductor E is always 0 and electric field is always 0. So these are the 4-5 points which we have to keep in our mind, and if we are following all these points, so we can get the answer. See, first of all, presence of the charge produces electric field. And due to the electric field in a conductor, charge polarized. Charge induced on the surface of conductor due to the effect of electric field. If the point where there is no electric field, there is no induced charge. See, as we know, inside a conducting shell, electric field is always 0. So here we can say there are 4 surfaces. One surface, inner surface of the inner shell, outer surface of the outer shell, outer surface of the inner shell. Third surface is the inner surface of the outer shell. Fourth is the outer surface of the outer shell. So these are the 4 surfaces we are having. So we would like to find charge distribution on each surface. Let here charge Q1, here Q2, here Q3 and here Q4. The first equation, as per the conservation of charge, in an isolated system, net charge of the system will remain constant. So here, if we are considering the first shell, this cell is not connected to any other shell or any other body. So whatever charge we have given, that will remain your constant. Okay, it can redistribute between inner and outer. That is another point. It can redistribute. So first equation we can say Q1 plus Q2 is equal to initial charge Q. First equation. Second equation, as whatever charge appear on the surface of cell, that is because of the electric field. See, if I am talking about the inner point of the inner shell, it means the location of the point 1. So this point is the inner point of the charge Q as well as inner point of the minus 2Q charge, and that charge is on the surface of the shell. As we know, inside the surface of a shell, electric field always 0. So at point 1 there is no electric field either due to the charge Q or due to the charge minus 2Q. So no electric field, so no polarization of charge, no redistribution of charge. So Q1 value will be here 0. This is your second equation. We can say Q1 is equal to 0. So from Q1 0 we got the Q2 is equal to Q. This is the one point. Next, if we are applying Gauss law, okay, this is your third surface, this is your fourth surface. Between third and fourth there is a material part. So we can say if we are making a Gaussian surface within the outer shell like this, within the outer shell, it means our surface is lying between inner surface of the outer shell and outer surface of the inner shell like this. So then we can write flux. Flux is equal to your charge enclosed by epsilon naught, and flux means here electric field into ds, and charge enclosed Q1 plus Q2 plus Q3 plus Q3 by epsilon naught. And since I made a Gaussian surface inside the inner point of the outer shell, so inside the shell electric field is always 0. So it is 0, it is your Q1 plus Q2 plus Q3, and Q1 already we have found 0. So we got it here, Q3 is equal to minus Q2. This is your third equation. Similarly, if we are talking about the outer shell again, the outer shell is also not connected to any of the shell as well as any other conductor. So whatever charge on the outer shell, that will also remain constant. So what is the charge on the outer shell we have given? Minus 2Q we have given. After distribution it came Q3 and Q4. So now another equation, fourth equation, we can write Q3 plus Q4 is equal to your minus 2Q. and this is your fourth equation. Now we can solve all the four equations. The first equation we got is Q1 0. On solving, Q1 0, then Q2 is equal to Q, Q2 is equal to Q, and Q3 is equal to minus Q2. So Q3 will be your minus Q, and if Q3 or minus Q, the Q4 will be also minus Q. The final distribution of charge is here this 0, Q, minus Q and minus Q. This is the final charge distribution of this cell. Now, so this is the one of the type of question here. Here some modification we can do. Suppose same question is given. Now if we are connecting or if we are making any of the shell as connected with the earth, let see here. Now in the same problem, now a small change I am doing here. Suppose if outer shell your earth, suppose outer shell earth, now then the question is that what is the final distribution of charge. So what will happen here, the new concept will come here. If any conductor is earth, then its potential will be 0. This is the one point here. Rest of the things will be as usual. See, first of all, conservation of charge. In conservation of charge, the conservation of charge is not applicable for earth shell. Why? To make the potential of this shell 0, some charge has gone or has come from earth to this conductor. That's why charge on this shell will not remain constant. So only thing is that charge on the inner shell remain constant. So for inner shell our equation will remain same. Q1 plus Q2 is equal to Q. As I told you, Q1 means point 1 is the innermost point. So every so electric field at the innermost point due to charge Q1 minus 2Q will be 0. So Q1 will be 0. Now this is your, you can say, first equation, this is your second, and third equation again by Gauss law if I am considering. So Gauss law when we are considering, so again we are considering the Gaussian surface inside the outer shell. When we are considering Gaussian surface inside the outer shell, the total charge will be your Q1 plus Q2 plus Q3. So E dot ds, that is equal to your Q1 plus Q2 plus Q3 by epsilon naught. But inside the shell, electric field 0. Inside the shell E is 0. So then our equation will be your Q1 plus Q2 plus Q3 will be 0, and Q1 is already 0. So Q3 is equal to minus Q2. So first, second and third, three equations are same as in the previous case. Fourth equation, here we cannot apply conservation of charge. We cannot apply here conservation of charge for the outer shell. So what can be done? We can calculate potential of this, and that potential we can make equal to 0. So first we are calculating potential on the outer shell. So potential on outer shell, potential on outer shell 0. So V is equal to your, due to all charges, so 1 by 4 pi epsilon naught Q1 plus Q2 by distance from here to here 2r plus Q3 plus Q4 by 2r. So we can get equation Q1 plus Q2 plus Q3 plus Q4 is equal to your 0. So V 0, Q1 plus Q2 plus Q3 plus Q4 is equal to 0, and as we have found Q1 plus Q2 plus Q3 is equal to 0, so that give us Q4 is equal to 0. This is your fourth value. So we are having this 4 answer, 1 Q1 0. So result finally Q1 0, Q2 is your Q, Q2 is Q, Q3 or minus Q2, so Q3 is your minus Q, and Q4 finally is 0. So now see the distribution of charge here. This is 0, Q, minus Q and 0. So what has been observed here? Earlier charge was minus 2Q on this shell. Now charge left only minus Q. It means minus Q charge has flown from the outer shell to earth. So that's why charge on this shell has been reduced, and this is the distribution of charge on each surface of each shell. Now in the same question here, we can little bit further we can change. See the here, then the result. See, now we will use this concept. If two conductors are connected together, their potential will be same. See how we can do like this. See that. Now our question is this: everything same two spherical charge conductor of radius r and 2r, one having charge q and minus 2q. In the previous two cases, we took in the first case charge distribution directly. In the second case, we have discussed, let if outer shell is earth, then what will be the effect. Third, suppose outer shell, let inner shell earth, then see the effect. If we are making inner shell earth, same concept, nothing is going to change here. If inner shell earth, so one thing is that we cannot apply conservation of charge for inner shell, because to make the potential of the inner shell 0, some charge interact between the ground and conductor. But we can apply conservation of charge for outer shell. So our first equation, Q3 plus Q4 equal to your minus 2Q. Let this be your first equation. Second point is that Q1 will be here always 0, because at position 1, it means no electric field here, so no charge will polarize. Third, again by using Gauss law, at the middle of the third and fourth surface, so we will get Q2 is equal to your minus Q3 minus Q2. Now next equation here, as the inner shell has been earth, so potential of inner shell must be 0. So first we are calculating potential of this. So potential of this your 1 by 4 pi epsilon naught Q1 plus Q2 by R, and potential due to this charge Q3 plus Q4 by 2R. Now since it has been earth, it is equal to 0. Q1 already 0 we have proved here. So Q2 by R, and this is Q3 plus Q4. Q3 plus Q4 minus 2Q. So minus 2Q by 2R. So we can conclude here Q2 value is your minus Q. So finally this is your fourth equation. So see the conclusion. Result, Q1 is 0, Q2 was minus Q, Q2 minus Q, then Q3 will be Q. If Q3 or Q, the Q4 is equal to your minus 3Q. The final charge distribution is this: 0, minus Q, plus Q, minus 3q. This is the charge distribution in the third case, in which we have made inner shell earth. See, before earthing charge was q, after earthing charge is minus q. It means how much charge has came from earth? Minus 2q charge has came from earth, and that minus 2q charge is making this shell at zero potential. So major conclusion we can say, in case of conductor facing surface, always we found q3 is equal to your minus q2 in all the cases by using by using Gauss law. So we can say, in case of conductor, facing surface of a conductor always have equal and opposite charges. So you can save your this time as well as equation directly by writing facing surface have equal and opposite charge, and it has come by using Gauss law, and it is compulsory because otherwise the electric field inside the conductor cannot be zero. Now these are the three situations. Now see the fourth situation. Fourth situation, I am not making any of the conductor as earth connecting to the earth. We are connecting both the conductor, then we can see the effect. See, now in this case we are not neither making any of the shell earth, we are just connecting these two shells, keeping the all situations are same. This is your spherical conductor of radius r, charge q. It is another spherical conductor of radius 2r, charge minus 2q. Now only we are joining these two. So here we will use this principle. If two conductors are connected together, their potential will be same. So first of all, equation is that directly we can write first of all q1 is always 0 because there is no electric field at inside point 1, and by Gauss law we can say q2 and q3, q2 plus q3 plus q1, that is also 0, second equation. And third, by conservation of charge. By conservation of charge, okay, individual conductor cannot have charge, their charge cannot remain same, because when two of the conductors are connected, so charge can flow between these two. So when charge can flow between these two, the sum of the charge in these two, it means q1 plus q2 plus q3 plus q4, that is equal to total charge. Total charge is q and minus 2q, it will be your minus q. So this is your third equation. So from these three equations, what we found? q1 0, q1 plus q2 plus q3 0 already, the q4 is 0 minus q. But we now want what is the q2 and q3 value. So these are the three equations. First, inside a electric field 0, that's why there is no distribution of charge. Second equation, by using Gauss law. Third equation, by using conservation of charge. And fourth equation, making a potential of these two same. So what we are doing, we are writing potential of this and potential of this, and both must be same, because after that flow of charge will stop. See, the potential of inner 1 by 4 pi epsilon naught. Potential of inner due to this charge. Due to this charge is your q1 plus q2 by r. Due to this charge, q3 plus q4 by 2r. This is the potential of the inner shell, and potential of outer shell. Outer shell due to this charge, q1 plus q2 by 2r, q3 plus q4 also 2r. So q1 plus q2 plus q3 plus q4 by 2r. So finally we can have q3 plus q4 by 2r, q3 plus q4 by 2r cancel. The q1 plus q2 is equal to q1 plus q2 by 2. can check from here. Now, after that, from here we can write Q1 plus Q2 is equal to your 0. Q1 already we have found 0. This is your fourth equation. So finally, the answer is that Q1 is 0. Q1 plus Q2 0. So that gives us Q2 also 0. If Q1 0, Q2 0, then Q3 also 0. And then all three is 0. The Q4 is equal to your minus Q. So finally, charge distribution is this 0, 0, 0 and minus Q. This is the distribution of charge when these two shell connected together. So what is the conclusion? All charge will come out only on its outer surface. So these are the certain relation or concept, and we can use like this. Now next is we will use the 3 concentric shell. Then we will check how to apply all these concepts in that case.